Charan and Boris in the morning. We decided in the afternoon to structure it with three more or less small keynote talks around agents, AI services, and we reform the front here. We have 3 seats already and have a small panel after those 3 talks, so prepare some questions arising from the talks for the time after that. We are close to the bar, which also gives us a neat idea beyond coffee, given the afternoon time, to have a splendid discussion at the panel. We have 3 distinguished speakers in the session, which is Albrecht Schmidt from the University of Munich, Aaron Ding from TU Delft, and Stefan Fischer from the University of Lübeck. And I first hand over to Albrecht for giving his talk. Thank you.
Thank you. Thank you. And I'm going to talk as AIs as a human-centered personal service, and with the subtitle From Cloud to Background. So perhaps a question: who has Claude services running at the moment to do something for them? What does it do, if you wanna share it with us? Yeah.
So literally, I'm making the modules for the distributed systems for sustainable transport.
So modules. And so I think if you look now, more and more people have services running. And some of them claim they have made fortunes, some of them have probably lost fortunes. So it goes both ways, because the people who win must get it from somewhere. So, and I have to. Okay, I try to hold it like this. So let me get started. So I think there's this question: what part of your cognition is nowadays technology free? And I think even the hotel puts cognitive aids in front of you. So I think most of us write. And I think this was not undisputed 2,500 years ago. Writing as a cognitive aid, because it changes how you think. People who cannot write have to remember much more than people who can read and write. And so your thinking is changing. And I think you can go back to Socrates, and he was quite sort of critical about the idea that people write stuff down because it makes people stupid. And I think in a way it does. We are probably much worse than people 3,000 years ago, academics, in remembering things, but we are much better at synthesis. And my take at the moment, we are at this point where we have moved from remembering, like storing stuff on paper, on other media, to where we have given synthesis to AI. And I think most of us, when we search today, it's not a search anymore. It's basically something where, it's a combination of stuff we called AI some years back. And I think one of the interesting things is, for those who have been longer in the business, once AI works, we typically don't call it AI anymore. So it's then for example, the on-screen keyboard is, when I did my PhD, this was AI. But nowadays, picking the right letter out of where you press with your big thumb is an on-screen keyboard. It's not AI anymore. So basically, we have, over the last 3-4 years, we're used to writing, summarizing, deciding, creating, navigating, remembering, acting. That's already there. And I think some of us use it more, others use it less. And I think at universities, in companies, there are big discussions how much we want to use of it or how much we don't want to use of it. And obviously, as you see those slides, who works with Claude knows those are Claude slides. And that's one of my arguments why we need personalization, because otherwise every slide looks sort of the same. But at the same time, it saves a lot of time. And I think what I want to go today, and where I'm really curious about getting some input, is really this idea of making AI a service that is really personal, proactive, context-aware, and agentic, which I think is a word which has drawn me into research some 30 years ago. I think there were multi-agent systems. I read a paper by Paddy Mays, I think in 96, 97, and got really excited. And this was basically on this intersection between distributed systems and AI. And I think we are now probably 30 years later at this point that a lot of those things which were in those visions we can build. Now, why is the human in there? I think a lot of people go with this hypothesis, AI can support cognition, metacognition, memory, creativity. But there was a really interesting paper already in 2024, which says, somewhere in the paper, human-AI combination performed significantly worse than the best of humans or AI alone. This is a tricky thing. So this assumption that if we throw the human in the mix, it will be better, is not as easy as it looks. We worked over the last year a little bit on this. And so what you see here is a performance, and the performance goes sort of from 0 to 20. It's the US law school admission test. It's sort of an extended IQ test with a lot of textual understanding. So basically, when you apply to law school in the US, you have to do that test. And if you just throw this test as it is into ChatGPT, not as a human, you basically take the test, throw it into ChatGPT question by question, you get this line. And that's somewhere about 13. What is interesting, if you use people, and we did not use, did this, that was done a lot of time, if you use regular people in the world, you get basically this orange distribution. The majority is below ChatGPT, but there's quite a significant portion that's above it. And now what's interesting, what we did, we gave people ChatGPT and the law school admission test. And this is the blue curve. And I think that the good news here, the first good news is the peak of people using AI is above AI without people. And about 50% of the people perform higher than the AI if they use AI. And they obviously perform much higher than they would on average. But the bad news, and I think that's interesting for the research, half of the people, they're really counterproductive. And so I recently said to the students in class, and it was on programming, if you belong to the lower 50%, look for something where you're not. Look for something where you belong to the top 10, 15, 20%, because then you have a chance to basically be valuable in this sort of combination. And there's another thing, and then as I go further. So this is Dunning-Kruger. I'm not sure, have you heard of Dunning-Kruger? It's basically the thing, stupid people overestimate themselves, clever people underestimate themselves. With AI, we act all like stupid people. This is basically the curve we have here. So basically, it's not huge, but the blue is the AI curve. So usually the typical Dunning-Kruger would be like this. But I think as we have the AI curve is very clear above. So if you use AI, you overestimate your abilities. And I think many of us have figured it out when we program. It seems like we're much better, much quicker. If we look at the time and it's 3 in the morning, it's like programming as it always was. We get in flow, it takes still some time. So it's interesting, and this is basically on this metacognition side. So our metacognition doesn't really work at this point very well with AI. So we are not really good in judging how well it helps us. And so why would we want to talk about service-oriented computing and this? I think what I'm really interested in is basically connecting cloud edge data and humans. I think a lot of things, the human plays a role, and I think the picture I showed earlier, there's a clear indication that putting the human in the loop will help, that a full automation will not achieve as well as the human does. And I think it's really this question, can we build services that amplify human cognition? That's something I have been working the last 15 years on, because that's something, getting smarter, I think is something I figured out very early on. This, if I can do that, that gives an edge. So, and I was never really good in writing in German. So, and I think spell checkers, probably I would not have studied if there would have been no spell checking. And I think that's something quite fundamental. And I think now we see this sort of question, how can we get there? And I think it's really this questions, and I think I've just put it in here, the HCI, basically about who is in control, what does agency mean, what is cognitive augmentation, and where does it sort of separate itself from automation, and where do we need to be transparent what the contribution of the human is versus what the contribution of the system is. And for me, this is a bit like this. I think we have understood services, and they technically, as well as with humans, they wait for a request. Then I think a lot of us have worked in the 2000s to 2010 on personal assistants, from the hardware all the way to technologies. And then the agents which really plan and work on behalf of us. And now I think this background agents, and I think there were quite some news items over the last 3 to 4 months on platforms, agent platforms, and I think there are even now sort of companies out there where you can run agents which you would not want to run on your own system because you don't really know what they do, but then people still connect them to their email and to their bank account, and what could possibly go wrong? And so for me, it's really this delegation is one of the tricky things, and we get told by people from Anthropic, just delegate the task. And then if you think quickly, who are the people who earn most in companies? Those who delegate well. I think it's delegating well is sort of a typical management skill. And so I think now we ask people, oh, you don't have to do it yourself, delegate it. And I think we know all that delegation is sometimes really hard. It is really difficult. And so why does this really matter at the moment? And I think a lot in life is serendipitous. Basically, it happens by accident. Who you sit next to on a plane, who you meet at university, sort of the place in a town where you end up. So they're not completely random, but there's a high random factor. And now, basically, if we build more and more on recommendations, where we have algorithmic stuff in the background, we lose a lot of the randomness. And I think what we know, and I think there's a lot of research in human-computer interaction, recommendation is very quickly steering. So people are usually extremely lazy. So who clicks through 100 links on Google? So I think Google, if you search for something, we have the tendency to have basically within the first 8 links, you get something like 90% of the clicks. And even if you search something like something very generic, where you have millions of hits. So what is the probability that they got it right? In Amazon, when you search for a t-shirt, it's sort of people search, especially on mobile phones, it's even smaller, the search space. People look for 10, 15 things, even if there are 5, 6, 800,000 of products. So I think this idea that recommendation is something where we pick is a sort of, it's a false friend in a way. So we think we have control, but we don't. And so basically it becomes sort of our life. And I think if you think of those, I think, what movie you watch next, I think Netflix, Prime, they have a big impact on that. And I think who you sit next to, who you walk with, who you go to the same restaurant with. And I think at the moment we expect that something like Google recommendation, Yelp recommendations, they're sort of not really clever. But you could really imagine, build an agent, look who else looked, who went there, to match up people all the way where you buy a flat or where you rent a flat, to whom you hook up. And I use this in teaching. I use Tinder as an example for basically what is the worst thing you could do with Tinder, sort of instead of teaching ethics, because I find that more interesting and people are more scared afterwards. So what is the bad thing you can do? And then you realize once you with these recommendations, you could basically wipe out whole races of and I think it's bad. And then you realize you give a lot once you put this into an agent, and I think we have seen, especially hooking up sort of the matchmaking agents. That was one of the first things people built because they were tired of swiping on whatever platform, and so they built agents. And I think when you think what you give up to an agent in that way, that's quite scary. And in the end, it's really this question: who is in control? Who decides what you get to see, what you know? Who creates the reality you live in? And who acts for you and in what way? And do you even know that this happens? Or do you believe it's your choice? I jump over this one and also jump over this one. And I think when we talk now about those tools, as I said earlier, it is really something, it's in a long tradition. And writing maps, calculators, and AI, it's not something fundamentally new. But the impact is fundamentally different because it's the reach is so much bigger than the reach we had before. And also our granularity of what we can do. So the granularity of basically writing a paper took you days. Now basically working on the granularity of that, you make the argument, you make the things you want to include, your ability to get things done gets much bigger. And obviously that could be in a positive way, but also if you go into the wrong direction, if you do bad things, I think your reach becomes much, much bigger. And this question of augmentation, automation is also not new. I think we see this throughout computer science, starting with Vannevar Bush, Lick Lederman, computer symbiosis, Engelbart, and Mark Weiss, so ubiquitous computing. So this story goes through that we want to augment. And I think that the key question, that's also something what basically is in the center of our lab. Can we design systems that outperforms humans and machines? That's the question I had earlier where I referenced this paper. Is there something where the joint performance is clearly better? And I think this is, to me, still a very open research question. And really this idea of having it personal, because at the moment a lot of the things we put effort in is making it personal, putting all the information in, that it really becomes something that's for me, that the slides, as I said, those slides, they look like Claude slides. Because I did not put if I would have put my personal context, the style guide from LMU inside, they would look like LMU, but I think I don't want to do that. We are typically sort of lazy. So I think this question, how does personalization work? And so the modes of personal AI is really, it should be reactive, but also proactive. It should be explicit if I ask it, but it should be also implicit when I need it. And at the moment, we really try to build those systems experimentally. And I jump to this one, and I start with this picture. That's something, it's work in progress, where we, at the moment, think of building a system, and I think people have been around in the Unicom community for a while, sort of putting a big computer in a rucksack and strapping stuff to people has a long tradition, and sometimes we learn stuff, sometimes it was at least fun. And here the idea is we put a lot of sensing onto the human, like 360 stereo cameras, 360 microphones, plus physiological sensing, and the idea is we get basically all the things you see here and your physiological reaction to it. And this becomes the context of your AI. And obviously, as we have argued, Steven Feiner did this for augmented reality in a similar size, and now it's a headset, and we would also expect that something like this. And I think the rationale for the experimental work was, we can put 12 kilograms on people, so this is a Mac Studio with a battery and a bit of other stuff, so we can really run it for a few hours. We haven't really completely built it yet. And the idea is then we take a base model, which we think of as the baby brain, the brain which is sort of joined for all humans in sort of the same way, and then we take the captured experience and we put this into a personal foundation model. And basically the idea is, can we optimize the benefit, like the engagement, the effectiveness for the human by putting this additional stuff into it? And we have a few ways of doing that. And it is really, if you think of recommendations, image generation, decision making, once the system has seen your previous decisions in skiing, in where you go on holiday, if it has seen what you have seen. So for example, when we generate with Stable Diffusion an image of a forest, it's at the moment very much a forest in California, or depending what model you're using, but probably all of us have a picture of a forest, and that picture is not random. It's basically, it evolved through our lifetime where we lived. And here the idea is that if I generate a picture, it should be a picture that's based on what I have seen. If it generates me recommendation, it should fit my life. And then I stop here. I have sort of three ways we're building this at the moment. I think one is we just basically build big contexts. So at the moment, something like the current Anthropic model, you can get context of 1 million tokens. And so the idea is everything you see and hear during the talk, transcribed, plus all the pictures you've seen transcribed, we can just put into the context, and just when you get up in the morning, your context grows. So this is one thing, so we put it into the context. The other one is creating a personalized or personal retrieval augmented system, and basically we take all the things and put it into a rack. We can do this also during the day because it's computationally not very. So basically, while we go along, we can basically feed the rack as well as the context, and the rack gives us basically that we can have provenance, that we know why we have certain decisions, and the context makes it much easier to find it. And then we have as a third one, which is basically what we at the moment, we haven't implemented it yet, envision to do overnight, that we basically fine-tune and retrain the model with everything we have seen and heard the previous day. So a little bit in a way what people think of dreaming, and I think the notion has also been now around with some of the models. And I think with this, there are quite a number of questions how to build these systems, how to build them that they scale, and how to build them that we as an individual keep control over them. Because in the end, I think everything you see and hear, you don't really want to share with everybody. So you want to keep it. And I think you don't want to even share it with yourself. Let me see here. You don't want to even share it with yourself, because there may be things in there which are uncomfortable if you have them in raw data. So the idea is, once we have trained and once we have put it into the system, we throw it away. So because I think the forgetting is also one of those things which is really critical. So the idea is, once we have fine-tuned the network, we throw stuff out. And the context basically is not completely reset, but something like this. We have 1 million tokens from yesterday. When we start this morning, we say, reduce this 1 million token to 50,000. So basically compacting the last day and having the other stuff there. And that's basically stuff we experiment with. And I think with this, I stop here, and then looking forward to the panel.
Okay, we have time for quick questions. Sharon.
Thank you very much. Great talk. So can you speak to the tension between serendipity and context awareness? Because this seems to be a contradiction on what you're saying.
So I think, to me, it doesn't really look like a contradiction. For me, it's really the context still gives me a lot of options. I think it's really the question, do I optimize? So basically, do I optimize, or do I have an element of surprise in there? And I think at the moment, we still have serendipity, because typically our algorithms are really bad. So we are not good enough to optimize.
But serendipity is not because of bad algorithms, it's actually because of very good algorithms. The original term by C.G. Jung
is actually being...
No. I go basically back serendipity in the real world. So basically, so if you look at, so I think we had this discussion a lot with people in historical sciences. A lot of the finds, if you look through, they were basically because they went through the library and got another book which they were not looking for, or they were basically digging for something, but basically came across something else. And I think this is sort of the notion of serendipity, not the algorithmic one, that really this notion of finding things and I think this is something, obviously, I think if you do full randomness, if you would not have context, it's meaningless. I think, and I think that's why you need to sort of constrain the randomness, and that's what I see. I think having the personalization and the context awareness to constrain, but having basically not going to a small set like 2 or 3 or 4 items, but going to a slightly larger set and then trying to get this there.
A quick last question for the panel.
Albrecht, on a quick question. There's a recent paper by the Google AI team. They observed that context can decrease hallucination, and in several use cases they observed that a threshold where hallucination exponentially grows. So getting context, controlling the amount of context is significant. Only as a comment.
I think there have been now a few more studies I've seen on where in the context to place stuff and how often to place stuff. So we have now experimented with, can I use context awareness to create a context that's reasonable? So for example, I have something and I put it somewhere at the beginning of the context. Let's say the last sentence I put at the beginning, at the end, and have it twice in there. Or the combination, I said, having sort of basically the big context and a rec in order to get provenance, to basically, because once you get, but I think this is sort of, these are the big questions, and I think they're, and everybody is probably trying to figure that out. And I think this context construction, what I send, especially once you have 1 million token now with the bigger models, I think we have been building now chatbots with students at university, and we will run it in school. So basically building these contexts which you basically grow, and then also how to, basically once your context goes over the context limit, do you go down to 80%? So I think we have experimented with, you reduce your context from basically 1 million token to 800,000, so you can add another 200,000, and then you compress it, or do you compress it stronger?
Okay, but maybe some serendipity at the end.